Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem LeetCode number 4 median of two sorted arrays. So we can see that we are given just two sorted arrays nums1 and nums2 of size m and n respectively, and we have to return the median of the two sorted arrays, and the overall runtime complexity should be big of log of m plus n. Alright, so now we can see that we are just given two nums1 and nums2 two arrays. In the examples also we can see we are given two arrays nums1 and nums2, and the good thing is both arrays are sorted, and now we have to tell the median of the combined two sorted arrays. So we can see if we merge them, so if we merge them, like here we are given 1 3, here it is given 2. Now if we merge them, we will get 1 2 3, and the median we can see that this is 2, and we have to return this in double. That's why output is 2.00. Now in the next similarly the next example 1 2 3 4 is example, two sorted arrays are given, and if we merge them, and we can see that number of elements are even, so there will be two medians 2 and 3, so we have to return the average of 2 and 3. So we will just return 2 plus 3 by 2, that is 5 by 2, that will be 2.5. So here the output is 2.5. So now the thing is how we can solve this. So the brute force approach which can come into my mind is that we uh, store uh, all the elements in a single array. We create a new array and store all the elements, like here 132, we have the elements 132. All right, and we store in such a way that this array is sorted. So remember the algorithm we used in merge sort function, in the merge function, when we used to write merge sort. So how do we merge two sorted arrays in a way such that the resultant array is also sorted using two pointers? So if we merge it and we create a new array, we can see this will be sorted, and now from the sorted array easily we can just know that if the number of elements are odd, then this means that the mid element will be our median. If the number of elements are even, then it means that two middle elements will be our median, and we will average them. So the first approach is taking we go of m plus n time, and we go of m plus n space also, where m and n are the uh, size of the two sorted arrays respectively. So the first is taking the time complexity also big of m plus n, and space complexity also big of m plus n. So this way, but here it is written we have to do this in big of log of m plus n. So now how we can do this? So here we can see we have reached the time complexity of we go of m plus n, and we have to go to we go of log of m plus n. So how we can go to this? So we can see that here it is written that arrays are sorted, and we have to search something median, we have to search elements. So we can definitely guaranteed that here we can apply binary search, but how we will apply binary search, that's later thing. So how we will convert this linear time complexity to logarithmic time complexity? So for that, first we have to understand. So I am taking an example. So I have taken these two arrays, two sorted arrays, array 1 and array 2, 2 4 6 and 1 3 5. So now our main aim was what? To find median. And let's find median first. What could be the median? So here what is the median? If we arrange this like 1 2 3 4 5 6, we can see that median is coming to be average of these two numbers 3 and 4, that is something about 7 by 2, and this is 3.5. So the average we are getting is 3.5. Now how we can convert this linear time complexity to that logarithmic time complexity, so that we should understand. So there is a trick, obviously, but that trick will be intuitive. So now, so first of all, we should think that what's a median. So we can see that if we draw a division line and we find that here and here there are equal number of elements. Let's say this is a boundary, and if here and here there are equal number of elements, we can easily say that the element, let's say total number of elements are even. If total number of elements are even, in this case we draw boundary here, and in the even case the the median will be what? The median will be the average of the two boundary elements. Alright, if we draw boundary, if we draw division line says that there are equal number of elements on the left side and equal number of elements on the right side, then in the even number of element case, the median will be the average of these two boundary elements, that is average of these 3 and 4. And if there are odd number of elements, let's say here there is 1 2, and on the, let's we draw anywhere else, let's say we have odd number of elements, so where will be our division line? So division line can be here where we were making division line. We were making a division line where if n n was here what, 6, so we were making division line at the n by 2, that is 6 by 2, that is 3, after the what, third element. So we draw division line after the third element. So here also, if n is 5 and we try to draw a division line after n by 2, that is n by 2 is what, uh, n by 2 will come what, this will be 2.5. But to, I mean, if we do a floor division, then n by 2 will be 2, 5 by 2 will be 2.5. So after 2.5 elements is nothing, so we will take a floor division. So after two elements we will draw division line. So in this case, where will be our median? Median will be at the right of the boundary. All right, understood. So let me rub this. So we understood that what is a median. So median is nothing but if we draw division line in the even case, if we draw division line and here on the left side and right side both elements are equal, number of elements are equal, then the left boundary element, that is 3, and right boundary element, that is 4, average of these two will be our answer. And in the odd case, again using the same formula, after that is n by 2, drawing a division line after n by 2, here also after n by 2. So here after drawing a division line, our median will be the right boundary element. In the even case, our median was the were both left and right boundary element, but in odd case our median will be just right boundary element. I hope you understood. All right, now you must be thinking why this boundary, but I think you, this is intuitive that what was a median. Median is just an element where left and right elements are equal. So this was intuitive. Now we are moving ahead step by step. Now this we understood this. Now let's say, let's say uh, what how we can proceed now. So we can see that we have two arrays, elements are 2 4 6 1 3 5, and we have two. If we draw a boundary line, we understood where we have to draw the boundary line and how many elements will be at the left. We also know how many elements will be at the left and how many elements will be at the right. So let me take the example of even case only, that is n is equals to 6, and the example is this array only. All right, example is this array only. So I am taking the even case example only, and after the even case, I will you will easily understand that what changes, or maybe nothing changes, we have to make in the odd case. So first we will understand everything about the even case, and the odd case will be automatically very easily. All right. So let I am take the same example only, and here we can see that where is my pen? Wait, where is my pen? So now, uh, how many elements are there? N is equals to 6. There are total even number of elements, that is even. So on the left side, how many elements will be there? On the left side, obviously n by 2, that is 3 elements will be there on the left side. So we have this boundary line, imaginary boundary line, we have to think, and here we have to put 3 elements. Here we have to put 3 elements, and here we have to put 3 elements. So which 3 elements we will put here? So, and we have to put here such a way that they are in sorted order. So which 3 elements should we put here? So there are 3 possibilities. First possibility is we choose no element from the first array and all 3 elements from the second array. So this is the possibility. So I chose no element from the first array and I chose all the 3 elements. So here I will write a small, I should write here that from array 1, from array 1, let me increase the size also, that from array 1, and here I will write from array 2. Alright. So now from array 1 I didn't choose any element, and from array 2 I chose all the 3 elements. So I will put here 135, and on the right side automatically, if I didn't choose from array 1 on the left side, no element from the left side, obviously I have to fill rest of the elements here. So here I will fill 2, 4, 6. They will be from array 1, and from array 2 there will be no elements left. So this is the first possibility. Second possibility is that we take one element from the array 1 and 2 elements from the array 2. So if I take, this is my boundary, if I take one element from the array 1, this will be 2, and well, rest of the 2 elements from array 2, this will be 1, 3, and fill other things. So from array 1 on the right side we will have 4 and 6, and on the from the array 2 we will have 5. All right. And now third case will be what? Third possibility will be what? Third possibility will be, and what will be our third possibility? See, in the first possibility we took 0 elements from the array 1. In the second possibility we took 2 elements from the array 1. And in the third possibility we will take all the 3 elements from the array 1. So taking all the 3 elements from the array 1 will make us 2, 4, 6 here, and from array 2 we are not taking any element because space is filled now. And in the right side from the array 1 no elements are left, and from the second array 1, 3, 5 all are left. All right, so we have just 3 possibilities, that either I choose 0 element from the array 1, or 1 elements from the array 1, or 2 elements from the array 1, or three elements from the array 1? So yes, I think more possible. I think there are four possibilities. We missed something. Zero elements from the array 1 and one element from the array 1, two elements from the array 1. We missed it. So I should write that also. I should shift it downwards. I should shift it downwards, and I will now write the uh, uh, next possibility. That will be our third possibility when we take only two elements from the array 1, that are 2 and 4, 2 and 4, and from the array 2 we will take one element, and on the right side we will be left with 6 and 3 5, 6 and 3 5. So these are the four possibilities that either see, we have this boundary, and on the left we have to fill three elements, and on the right we have to fill three elements. So we have four possibilities, that either we take zero elements from the array 1, or either we take one element from the array 1, either we take two elements from the array 1, or we take all the three elements from the array 1. All right. So now what we will do, we will check all the possibilities one by one. First 0, then 1, then 2, then 3, which is giving the correct arrangement, so the case which will give us the correct arrangement, we can easily find our answer. Let me tell you how. So uh, first of all, either we decide to go linearly, 0 1 then 2 then 3. So why to go linearly when we have to check, start from 0 and end up to 3? So why to search go linearly? Why we can't apply binary search here? That why we can't just uh, set our low as 0 and high as 3, high as 3, and now my mid will be what? Mid will be 3 by 2, that is 1. Now we directly check from this case, and next time we will eliminate our one of the right or left half. So now this my mid is 1. So now I will check for the case where I will take one element from the array 1. So this was our case. I am taking one element from the array 1. That is 2. I will take the first element, and this we already wrote it, our one case. Now we have to check whether this arrangement is correct or not. So how we will know that this arrangement is correct or not? So this 2 we got, all right, from the array 1, and these 1 and 3 we got from the array 2. Okay, I should write it here also. I should copy it, and I should, I think, paste it around here. All right. So here also, and here also. So now we can see that uh, we got 2 from the array 1, and for this arrangement to be correct, we know that this these 1 3 are sorted, this 2 is sorted, this 4 and 6 are sorted, 5 is also sorted. So we just need to check that whether the left elements are less than or equal to right elements or not. This is basically our sorting, that we need to check all the left elements are less than equal to the right elements or not. So but why need to check every element? We can just check the boundary elements. So on the boundary we have, from the array, from the array 1 we got 2. So now how, from where we should compare this to? Should we compare this to 4 and 6, or we should compare this 2 with 5? So we already know that this 4 and 6 was uh, already part of array 1, and that was already sorted, so no need to check no need to check uh, this way, no need to check this way. We don't this is not necessary, because 2 was already 2 4 6 were already from the same array and they were sorted. So we can just cross check that is 2 less than 5 less than equal to 5 or not. So here yes, 2 is less than equal to 5, good. And now from here also we can check the boundary element, that here we got 3 and here we got 4, and we just need to check that is 3 less than equal to 4. So we got both 2 is less than equal to 5 correct, and 3 is less than equal to 4 correct. It means that this case is yielding us the possible answer. All right, so this case is giving us the correct answer. So now what we can do, that if we got the correct case that is satisfying the cross checks that left elements are less than equal to the right elements, so now we can easily find the answer. Now what will be our answer? So we already know that the when number of elements are even in this case, so the and this is the boundary, so what will be our median? Median will be the average of the left boundary element and the right boundary element. So here the left boundary element will be what? Here we have two boundary elements, 2 and 3. So what will be our left boundary element? What will be our left boundary element? This will be nothing but maximum of 2 and 3. So here from the left we can just check the maximum of the, let's call this L1 and let's call this L2, and let's call this let me write this with the different color. Let's call this L1 and let's call this L2, and let's call this R1 and let's call this R2. So now we can easily say that the left boundary element will be maximum of L1 and L2, and the right boundary element will be the minimum of R1 and R2, because they are the starting ones. So this way we will find here, in this case our left boundary element will be the maximum of 2 and 3, that will be 3, and the right boundary element will be the minimum of will be the minimum of what, 4 and 5, 4 and 5, this will be 4. So our average will be what, 3 plus 4, our median will be what, 3 plus 4 by 2, that will be 7 by 2, and that will be what, that will be what 3.5, and that was our answer. Actually that was our answer, that was our answer, because we were what array we were having, 2 4 6 1 3 5, and if we arrange this in sorted order in a single array, we will get this way. And we have two medians, 3 and 4, so our median will be what, median will be 3 plus 4 by 2, that is 3.5, and here also we got it. So this was the logic. Now you must be thinking, what if this case was false? What if this case was false? What if let's say we we are on this case? All right, let's say we got our mid as 3. So how we will decide that here we can see that if we compare 6 and 1, 6 is coming, 6 should be less than equal to 1, but this is not true. So it means that this arrangement is not true. So we are standing at our mid here. So where we should move, on the left side or on the right side? On the left side or on the right side? Obviously left side we have to move, but how we will decide? So we can see that if we got this was 6 was what, L1, and this was 1 was what, R2. So when we got L1 greater than L2, it means that on the left side, that means on the left side, we don't want this. We don't want this 6. We want this 6 on the right side. It means that we have to reduce the number of elements from the left side. It means we have to reduce the number of elements from the left side. So if we have to reduce the number of elements from the left side, it means that we have to take less elements from the on the left side. It means we have to take less elements. So it means that we have to move left side. For taking less elements, we have to reduce our mid. So to reduce our mid, we have to move left side. And suppose we were at 0 when our mid was 0, and if we check here, 5 is less than here what was coming, what it was coming. If we take, yes, this was the case. This was the case. When we compare 5 and 2, and 5 should be less than equal to 2, but what happened here? When this was what L2 and this was R1. So when we got L2 greater than R1, it means that it means the vice versa of that thing, that we want less element. This 5 should be on the right side. It means that we want less element on the L2, but in the previous case, it was when L1 was greater than R2, it means that we want less elements in L1 from the array 1, and this 0, 1, 2, 3 was all about the number of elements taken from the array 1. So it means that if L1 is greater than R2, we don't need this 6. It means that we have to reduce the number of elements from the array 1. It means that we have to reduce our mid. Alright, so in the vice versa case, in the else case, when we are getting L2 greater than R1, it means that we have to move, we don't need this 5, we don't need this 5. It means that we have to take, we don't, uh, we, it means that we don't have to take L2. It means that we have to remove this 5. So how we will remove this 5? When we will reduce taking elements from array 2, and we will start taking elements from array 1. And when we have to start taking elements from array 1, it means that we have to increase the number of elements in the array 1, and it means that we have to start taking more elements in array 1. It means that we have to increase our mid. Alright, understood. So this was the case, that how we will decide in the case when uh, the rules are violating. It means that we have to change our mid, either we have to move on the left or on the right side. So this way we will decide. When L1, when we need more elements in L1, it means that we have to move to the right side, and if when we will need less elements in L1, uh, I mean when we need more elements from array 1, we will increase our mid, and when we will need less elements from array 1, we will uh, reduce our mid. Alright, so this will just decide that if L1 is violating or L2 is violating. So simple, this was the check, this was the case, that if L1 is coming greater than R2, so if L1 is coming greater than R2, then we have to move to the uh, if L1 is coming greater than wait, when L1 is coming greater than R2, it means that we have more elements there and we have to reduce it. So we will move to the left side. So we will reduce our mid here. So here we will reduce our mid, and when L2 will be greater than R1, then we will increase our mid. Alright, we can see here also, when L1 was greater than L2, we have to reduce our mid. Alright, so this way we will go. Now if I implement this, if I implement this, so this was the whole algorithm, and now if I have to implement this, so I can just simply, we simply know. So now, first of all, the basic things that we find the size of both the arrays, that is n1 and n2. This will be what? Nums1 and nums2 dot size. All right. Now this n will be for checking n1 plus n2. I will do n1 plus n2 also. And now what we have to find? We have to find L1, we have to find L2, and but wait, we have to find them in the while loop. We have to find L1, L1, L2, R1, R2 will be different in every cases. So no need to find it globally. Just assign a low. Low will be 0, and high will be what? Now int high is equals to what? So what we were doing here, either we were taking 0 elements from the array 1, or 1 element, or 2 elements, or 3 elements from the array 1. So basically, if we write high as n by 2, then what if there are not much elements in the array 1? Then this will give us error. So we should mark our limit as n1. Okay, so this way we will go from 0 to 3. Either we take 0 elements from first array, or 1 element from first array, or 2, or we take every elements from the first array. Then you must be thinking that what if it exceeds the uh, half? But when it will exceed the half, and then our case will not match, then binary search will automatically move to left and will reduce mid. So that's why we are setting our low as 0 and high as n1, because we have to decide to take number of elements from array 1. So that's why either we took 0 elements from array 1, or 1 element, or 2 elements, up to total number of elements. Let's say size was n1. So uh, high was n1. And now you can see that what was our time complexity. Time complexity will be what? We are moving from 0 to n1, and we are doing this using binary search. So time complexity will be what? We go of log of n1. So to reduce this n1, to reduce this time complexity more, we should take n1 smaller. So we will take this uh, we will take the smaller array as our first array. We will take a smaller array as our first array. So that's why I will also make sure in the starting that if n2 is coming, if n1 is coming greater than n2, then we should swap. Then we should swap both the arrays, and or swapping is not a good practice, because this way we are modifying the original arrays, the original data. We are modifying the original data. So the good practice will be like calling this function again by passing nums2 and nums1. So that will be a good way, rather than modifying the original data. So but here i am just uh, I'm just swapping it, or I should also do the same. I will call because I will always practice the good way. So I should not delete, I should write here just this function again. I should call this function again, and here I will simply pass without swiping nums2 and nums1. All right, and the answer which it will give, we can just return it. so that it doesn't go downward. Now we have n1 as our smaller size. Now while low is less than equal to high, first of all I will find my mid. My standard mid was low plus high minus low by 2, and we have to find in every case we have to find L1, L2 and R1 and R2. So what will be my L1, L2, R1, R2? So these are nothing but the boundary elements. So let's say that mid was what? Let's say mid was 1. All right. And the array were what? The array were, if I'm not wrong, the array were 1 to 5, 1 to 4, and 1 the array were 246 and 135. 246 and 135. 246 135. So mid was 1. It means from this array 1, from this array 1, and this was array 2. From this array 1, I need only one element. And if I write the indexes were 0, 1, 2, and 0, 1, and 2. So, so what will be my L1? So L1 will be what? L1 means that the uh, left that the last element from the array 1, that is if I want one element only. So see we want one element, okay, and we can see that if I try to find array 1 of uh, one element is what, one element is 2 here, and what is the index here? 0, and this is what, 1 minus 1. And first of all, what was our L1? Our L1 was the rightmost element which we are getting from the arrays, from the array 1. All right. So if I have to get only one element, and if I just say that give me array 1 of mid minus 1, this will give me the this will give me array of this will give me array 1 of 1 minus 1, that is 0, and this will be 2. Let's say there were more elements here, and again if I said that give me array of m minus 1, this will yield me 2. This is That's what I need. I just need this 2. I don't want to care about these elements, because see, I want the largest element here. I want the boundary elements. So I just need the boundary elements. So that's why I will just ask for mid mid minus 1th element. All right. And also we will just check that this mid minus 1 is not going uh, out of boundary also. And now comes to L2. L2 will be what? L2 means that we took one element from here, and on the left side we we need how many number of elements? We need exactly n by 2, that is 3 number of elements, and we got one element from here. It means that we are left with two elements on the left, and these two elements on the left we will take from the array 2. So we can just say that give me this 2 minus 1th element. Like here I want only one element from the array 1, that's why I wrote 1 minus 1. So similarly, if I want two elements from here, and we know that this is sorted and these are 0 based indexing, so starting two elements will be 0 and 1. And if I want to just care about the boundary element, So I just want this 3, nothing else. So I want just this 3. So this will be 3. And if I write the general formula here, so general formula will be what? This will be n by 2 minus m minus 1. How? Because see, we got one element here, and we on the left there should be total n by 2 elements. We filled this by one element, and just we are left with n by 2 minus m element. And if it is 0 based indexing, so I wrote minus 1 here. All right. So now right elements. Uh, if I talk about right elements, so I just need the boundary elements. So if I got here 2, so the right element, the starting right element will be what? 4. So what is 4? Array of mid? No problem. This is just array of mid, and on the right also this is just uh, array of array 2 of n by 2 minus m. All right, because we want just starting boundary elements. So here I will get this 5, just right element to the left boundary element. So I got this L1, L2, R1, R2. So I will write here also formula for L1, L2, R1, R2. So L1 is array 1 of m minus 1. So, but we will also check for the boundary that m minus 1 is should not go out of bound. So I should make a check here that mid minus 1 should be greater than equal to 0, and if it is true, then I will just find nums 1 of mid minus 1. Else else you must be thinking that in such cases where from array 2 there are no elements, so in these cases when we compare this empty with this empty, this should return as true. So why not we take here minus infinity, and why not we take here positive infinity? So this is easy because this will always return true, because left side is will be always less than equal to the right side. So if mid minus 1 is, if this is not true, it means that mid minus 1 is not existing, that elements is not existing. So the left element is not existing, it means. So we should put here int min. Similarly, now L2 will be what? L2 was what we defined here, array 2 of n by 2 minus m minus 1. So but again we should check that this is not going out of boundary. So similarly we will write here that n by 2 minus mid minus 1 should be greater than equal to 0, and if it is true, then I will say that give me the n by 2 minus m minus 1 from the array 2, n by 2 minus m minus 1 from the array 2, and if it is not true, then make it int min on the left side. And similarly r1 and r2, so r1 was what? Array 1 of mid. So again I will first of all check that uh, this mid which I am talking about should be less than n1. Why? Because if I am saying that give me nums1 of mid, and what if mid comes to be n1, and this will go out of bound, because we are handling 0 based indexing, so mid should be less than n1. Else on the right case, if element does not exist, we will make it positive infinity. And r2 also, what we have to do, n by 2 minus m. So here I will write n by 2 minus mid minus no minus. So here we will write here nums2 of n by 2 minus mid, else we will write here int max. Alright, now we got L1, L2, R1, R2. Just we have to check now that if L1 is less than equal to R2 and L2 is less than equal to R1. If both are correct, it means that we got our correct case potential answer. So now we will just check what is n. If n is odd, if n is odd, yes, that's the case. In the starting, I said that we will we talked about the even case element, but the odd case element in the starting we talked about also that let's say there are only odd number of elements and we have boundary here, and on the left side we need n by 2 elements, that in this case 5 by 2 elements, that it means 2 elements, so 1 2 will be placed here and 3 and 3 4 5 will be placed here. So it means that we will have only one median. So in the odd case, the right boundary element will be our answer. So we will say that return the right boundary element, and right boundary element will be what? The minimum of R1, R2, minimum of R1 and R2 we will return, and if the number of elements are even, then we have to return the average. So first of all, I will create a double variable, let's say answer, and what I have to do, I have to just first of all I should convert the left boundary element will be what? The maximum of L1 and L2. Alright, and this I will add with the, because this double, because we have to return this in double, alright, that's why. Now, and I have to find average. So how we find average? We already know. And the right boundary element is what? Minimum of R1 and R2, and rest we just average it with 2.0, and here we should create the correct brackets. Now when max of L1 L2, this left boundary element will be converted to double, and when we will add this double with another integer, this will convert to double, and we will divide it with 2.0, this will give a double value, and we store it in double, and now we can just return this as answer. Let me check the parenthesis. L1 L2 is correct, double is correct, but wait, this way we not write double. In C++ we write double in bracket, and now after this is calculated in 2.0. Okay, now if we got a case that is not correct, if my case is not correct, so it means that either L1 will be greater than R2. So let's say if L1 is greater than R2, it means that we need less elements, so we need to move left. So high will be equal to what? Mid minus 1, and in the else case we have to move to the right side, so low will be equal to mid plus 1, and at the end if and at the end we should return a dummy variable that will never execute, but it's a good practice. And if I just run this and check whether we haven't made any mistakes, so this, yes, I wrote here m, but I should write here mid. Anywhere else, if I run this, so uh, somewhere we are missing something, that average is not giving us correct answer. So what I said, that int n1 is equal to nums1 outside int n2 is this, and if n1 is greater than n2, because n1 should be smaller, so I called this function. We can swap also, but I don't want to modify the original data. And n is n1 plus n2, total number of elements. Low is 0, high is n1, less than equal to high. Mid, we found it correctly. L1 is what? Mid minus 1 is greater than equal to 0, and nums1 of mid minus 1, okay, and L2 will be what? N by 2 minus mid minus 1, if it is greater than equal to 0. So because left elements will be n by 2 minus mid, and we will get from here, from the next array, and from R1 will be what? Nums1 of mid, and we are handling the thing also. But yes, we are not writing here n1. We should also, we didn't complete the uh, code line. And now if I run this, again we are missing something, that n by 2 minus mid is also less than n1, and we are good to go. And if L1 is less than equal to R2 and L2 is also less than equal to R1, it means that we are correct. And if the number of elements, total number of elements, that is n1 plus n2, are odd, it means that we have to return the right boundary element, that will be minimum of R1 and R2. So in this case, minimum of R1 and R2, when we have uh, right element, that was 3, and that was correct median. And in the else case, we will find the double. Double will be what? The average of left and right elements. Left element will be what? Maximum of L1 and L2. This is L, not 1. And if I submit this, and we can see that we made some mistake, that in the R2, we are doing n minus 2 minus mid. We are handling nums2 array. So we should write here n2 in place of R2. Alright. So if I now submit this and check whether we are able to pass all the test cases or not. So yes, finally we have solved this problem successfully now. And now if I talk about the time and space complexity, so we all already know, I have discussed it, that time complexity is big O of log of logarithmic of n1. Yes, n1, where is the, and where n1 is the uh, size of the smaller array. And space complexity, we can see that we are not taking any space, so space complexity is big O of 1. And now we have solved this problem successfully, and this was all about this problem. I hope you understood. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.